Let us consider equilibrium equations for a rigid body under a three-dimensional system of forces. In this case, from the equilibrium conditions we obtain 6 equations to determine the projections of the principal vector on the axis x, y, z, and the projections of the principal moment on the corresponding axis being equal to 0. For solving problems in practice, these equations can be transformed into 6 equations, namely, the sum of projections of all forces on the axis x is equal to 0, the sum of projections of all forces on the axis y is equal to 0, the sum of projections of all forces to the axis z is equal to 0, the sum of moments of all forces with respect to the axis x is equal to 0. The sum of moments of all forces with respect to the axis y is equal to 0, and the sum of moments of all forces with respect to the axis z is equal to 0. Analyzing the state of equilibrium of an upper berth in a railroad car, we obtain a three-dimensional system of forces and, introducing a reference system of the x, y, z coordinates, we can write down 6 equilibrium equations. The number of independent equations is reduced as particular three-dimensional systems of forces are considered. You have already made yourself familiar with the system of concurrent forces, and in this case, 3 equilibrium equations are written down as the projections of the principal vector on the coordinate axis. It means that there are 3 equations: the sum of projections of all forces on the axis x, the sum of projections of all axes on the axis y, and the sum of projections of all forces on the axis z. Considering the system of forces which lines of actions cross a certain axis, the number of independent equations is reduced from 6 to 5. In this case, we can write down the following equations: the sum of all projections on the axis x, y, and z, and the sum of moments of all forces with respect to the axis x and y. When the lines of action of forces lie in parallel planes, we also obtain 5 independent equations, but this time they are the equations for projections of all forces on the axis y, z, and 3 equations: the sum of moments of all forces with respect to the axis x, y, and z. Let us consider yet another important case, namely a system of parallel forces. When dealing with such system of forces, we have only 3 equations instead of 6. Namely, when we choose the axis z parallel to the lines of actions of forces, we then obtain the sum of projections of all the forces on the axis z, and also the sum of moments of all the forces with respect to the axis x and y.